Guys, we are in lesson 4.5 today, and that is page number 84 of your note packet. Okay, so we are going to get started. Page 84 in your note packet, and that's note packet 2, part 2, I should say. Okay, lesson 4.5 is when we're dealing with slope-intercept, which you have seen before. The form of slope-intercept is y equals mx plus b. Okay, and that's where m is the slope and b is the y-intercept, okay? And so we can pull out from equations of lines the slope and the y-intercept. Okay, so let's start with the first one. Y equals x plus 5. This is a super easy one. There's a 1 attached to that x, so it's 1 is the slope. And the y-intercept, which we always list as b, is 5. Okay, and then they get a little trickier as we progress through this page. On this one, we have to get it into y equals mx plus b form. So I need to move that 2x over to the right. We get y equals 2x plus 9. And then we have a slope of 2. We can easily identify them. And a y-intercept of 9. Okay? 14x minus 4y equals 10. Well, we got to get a y by itself. And we have to move that 14x over first. You guys have done this before. Okay, remember, we want our x term before our constant. So I'm going to do negative 4y. My negative 14x goes first. Plus 10. Then I'm going to divide everything by negative 4. Okay, I get y equals, what is that, 7 halves. A negative over a negative is a positive. And here we get minus 5 halves, which is 2.5. Okay, just a little word of advice. When you're doing these slope-intercept, okay, I want you to leave the slope as a improper fraction because you're obviously doing rise over run. When you're talking about your y-intercept, though, you change that to a mixed number, okay? And then we can pull out our slope and y-intercept. We have a slope of 7 halves and a y-intercept of negative 2.5, okay? Going down to D, let's see. Oh, this one's in a nice form already. We just have to divide by 4 for every term, right? We get y equals 3/4 x. What's minus, let's see, 15 over 4 is going to be, 3 3/4, right? So we got a slope of 3/4 and a y-intercept of negative 3 3/4. Okay, we'll do one more. E looks more challenging, so let's do that one. Again, we have to get it in y equals mx plus b form. We've got to get that y by itself. So I'm going to move my 9x over. I get negative 8y equals negative 9x plus 54. I'll divide by negative 8. I get y equals, let's see, a negative over a negative is a positive. I'm going to leave that as improper. Positive over a negative is a negative. 54 over 8 becomes, what? Negative 6, I believe 3/4. Okay? So we've got a slope of 9/8. And we've got a y-intercept of negative 6 3/4. Okay, we'll skip the next one and we will go on to the next page. Okay, which is page 85. Okay, so when we're graphing these equations of lines and they give it to you, this is standard form right here, right? We got a standard form. You can do one of two things. Way one is to find x and y intercepts, okay? And we know how to do that. We know an x-intercept is when y is 0. So I'm going to plug 0 in for y. I've got 4x minus 3 times 0 equals negative 6. Divide by 4. What, I get x equals, what, negative 1.5, right? So I've got negative 1.5 comma 0. I do my y-intercept, which is 0 comma a number, which means I plug 0 in for x and solve for y. 4 times 0 minus 3y equals negative 6. We get y equals 2. That's going to be 0 comma 2, okay? And then we would graph both those points and connect the line, and there we have it. Now, another way to graph when you're in standard form is to convert to slope-intercept, okay? So convert to slope intercept. And that's obviously y equals mx plus b like we saw on the previous page. So we just did that, right? 4x minus 3y equals negative 6. Subtract 4x from both sides. I get negative 3y equals negative 4x minus 6. Divide by negative 3. We get y equals 4/3 x plus 2. Okay, and from that I'm going to pull my slope, which is 4/3, my y-intercept, which is 2. Okay, and I'm going to graph that. I graph that by graphing my y-intercept and then counting my slope. Okay, let's, oopsie, whoa, that was really bizarre. Okay, we'll believe that. You guys saw that. Moving right along. Let's see, y equals 8y minus 2x equals 4, okay? It's really not in standard form the way it is, right? I always like to get that negative 2x first. It bothers Mrs. Quinto, so we're going to do that. And again, we can find our x and y intercepts easily. We've got negative 2 times 0 plus 8y equals 4. So y equals 1/2. Okay, again, we're just finding our x and y intercepts in order to be able to graph it. We've got a negative 2x plus 8 times 0 equals 4. We get x equals negative 2. So you could take those 2 points, plot them, connect the line. You've got your graph, okay? The other thing we can do is we can convert to slope-intercept, right? Or, yeah, slope-intercept. We've got negative 2x plus 8y equals 4. I'm going to go ahead and start moving things. I add 2x to both sides. I get 8y equals 2x plus 4. Okay, I'm going to divide everything by 8. I get y equals 1/4 x plus 1/2. So in order to graph that, my slope is 1/4, my y-intercept is 1/2, and I would graph my graph my y-intercept and then count my slope. Okay, moving right along. This is all good and fine, but now that we're in algebra, I'm going to teach you a shortcut. Okay, so we can do something. Let's see, there's a pattern in converting from standard form to slope-intercept form. What is it? Okay, well, if you've looked at the previous examples, let's look down here for a second, okay? If you just look down at these examples, right? Oopsie, let's draw that right here, okay? You can see where they convert, right? And they convert it down to y equals negative 2x plus 7, okay? They did the same thing in each one of these problems. But I hope you're starting to see that there's a bit of a pattern. The slope, okay, so let's take a rewind for a second. When we're in standard form, we are ax plus by equals c, okay? If I want to convert this easily to slope-intercept with doing all the moving and doing my inverse operations, there's a pattern. The slope is actually negative a over b, and the y-intercept is actually c over b. So if I take this problem right here and I do 6x plus 3y equals 21, I can go through all these steps up here, right? Or I can just say, well, the slope is negative a over b, which means negative 6 over 3, which is negative 2. I can see my y-intercept is what? C, which is 21, over b, which is 3. And look what I have. Y equals negative 2x plus 7. Same thing as up there, they match. So you can use this shortcut anytime you like, okay? Next page. We're moving right along here. What do we got? Graph the equation 2x plus 3y equals 9, okay? Rather than do my y and x intercepts, I'm going to go ahead and I'm going to convert this to slope-intercept, but I'm going to use the shortcut I just taught you. We know m, or my slope, is negative a over b. Okay, we got a, b, c. This only works if we're converting from standard to slope-intercept. Negative, the a is 2, over b is 3. So I have a slope of negative 2/3. I have a y-intercept of c over b. Okay, that's going to give me 9 over 3, which is 3. And now I can do y equals negative 2/3 x plus 3. And I've got it. Okay, now I just want to make sure you're clear on the order of graphing. We are going to graph the y-intercept. Okay, this is review. And then we are going to, from the y-intercept, graph your slope. Okay, so let's do that. Actually, let's blow this up a little bit so we can actually see it. Okay, x and y axes are already labeled. I'm going to use a scale of 1, and I'm actually going to label that, okay? Let's see, what was my y-intercept? It was 3. So we're going to go up to 3, and we're going to mark our point, and then we're counting a slope. It's a rise over run of negative 2/3. So I'm going to go down 2 over 3, down 2 over 3, down 2 over 3, etc. Okay? And if I connect those, let's see if I can get my tool to work this time. We're going to go up here. That's very close. Okay? You guys are always, oh, well, that's no good. Let's get the eraser going. We are going to draw. Put our arrows on either end. Okay, you guys are going to use a straight edge, and then our last step is to write the equation of the line. And there you have it. Okay, let's look at the one below. The graph of the equation is 7x minus 5y equals 20. Okay, I'm going to go ahead again and use my shortcut that I just taught you. M equals negative a over b. Okay, so remember we've got a, we've got b, and we got c. That's going to be a negative 7 over a negative 5. So m equals 7/5. And we've got a b of, c over b. Sorry, I lost my train of thought for a second. We got 20 over negative 5, which is going to give me a negative 4. Okay, so I want you graph. Okay, you graph those on your own. Okay, moving right along, we are in the home stretch here. I want you to go to the next page. Oopsie, let's see what we got here. This kind of blew up on me and I didn't mean for it to. Okay. Well, this is bizarre. I don't know how this happened, but we'll make it work. Okay. You know what? We're going to skip this one for now, and I actually want to go down to the bottom, example 3A on page 88. Okay. And we are talking here about finding the value of k so that the lines through the given points are as described below. Okay, so here we want a parallel, and here we want perpendicular. We know that parallel lines have the same slope. So for line 1, I'm going to find the slope. We have y2 minus y1, so 8 minus a negative 7, which becomes a plus. And we have 3 minus a negative 2, which becomes a plus. So what do we have? A 15 over 5, which is 3. So I have a slope of 3. We know that parallel lines have the same slope. So we want the slope of this line 2 to equal 3. So I'm going to go ahead and I'm going to say 3, my slope, equals k minus a negative 6, which becomes plus 6. And we've got 2 minus negative 3, which becomes plus 3. So we're going to have 3 equals k plus 6 over 5. And now I hope you recognize that it's just a matter of cross products, okay? What do we have here? 3 times 5 is 15, equals k plus 6. Subtract 6, and we get k equals 9. So if we were to plug 9 into that line, that coordinate, we would get parallel lines, okay? Moving over to the perpendicular. Okay, we are at, okay, for perpendicular, we have opposite reciprocals, okay? Here was my slope. So my perpendicular slope is going to be the opposite. So the opposite of positive is negative, and we're going to have 1/3, okay? So we just set it up the same way. y2 minus y1, so k minus a -6, which is +6, over 2 minus a -3 equals my -1/3, okay? That becomes 5. We're going to do cross products. -1 times 5 is -5, and we've got 3 times k plus 6, okay? -5 equals 3k plus 18. I'm going to go ahead and I am going to subtract, whoopsie, it would help if I changed. Subtract 18 from both sides. I get, let's write down here, 3k equals, what is that, -23. Divide by 3, I get k equals -7 2/3. Okay, that wasn't so bad. And we are in the home stretch. If you look at 3B on page 89, I actually, well, it would help if I could get my tool right. I want you to do this one on your own, okay? So if you would, on your own, I will check in class, okay? And that is it. We are done. You can go ahead and do that problem and then